Assalamualaikum sir. This is Ahmed Akib Jodhpurim from CSE 331 Section 2 Group 3, and I'll be presenting the project presentation for our group. Now I will be using our report, your slide that you have provided, and this PDF file, and obviously Proteus to demonstrate our project. Now, what is our project? Our project was to implement an encryption decryption system using 80 mega 328P microcontroller. Now you have given us 16 sequences that will get these designated outputs. Now to get these outputs, we need to have different expressions that actually makes our work different to other groups' work. Now another interesting thing that our project focuses is this part, that this implementation has to be in two different ways. First one is using Arduino default read write functions, and second one is using register level alternatives for the same task. So I have done two programmings for our work for the same work. One is using functions like digital read, digital write, and another is register level programming, where we had to check these pins manually, and our desired pins were checked manually, and then we programmed them accordingly. Now let me start with a short introduction that we have here, that I have given already the introduction, but let's move on to the next portion. What we have actually used in our project. Our software equipments were Proteus 8 Professional, obviously to demonstrate our simulations, Arduino IDE where we did our programmings, and Logisim where we built our circuit to express our Boolean expressions. Now this table represents that these will be our inputs and these will be our outputs. Okay. Now first we have to derive this Boolean expressions, which is very key to our project. For this we have used a website that you recommended, a K-map solver, where we have derived our four equations. And if I go down, this is how we did it. This is how we did for the expression of O3. Let me keep it side by side. O3, and this way we got the expression of O2. This way we got the expression of O1, and this way we got the expression of O0. These are the outputs. Now we have used these equations to form this circuit which expresses our requirement and our output. For example, all these inputs are 0, no 5 volt is given. Now according to our chart task, we should be getting 0 1 0 1, and if we see here, yes, we are getting 0 1 0 1. So this logic circuit fulfills our requirement. Now moving on to the next part, this part shows us few screenshots of our work. So I will be now turning on Proteus to demonstrate our work and then get back to this report site again. So let me turn on. This is the demo one. Oh, I think it's already on. Yes, it is on. Okay, yes, this is on now. So this is our circuit that we have. This is our circuit that we have built. This is the Arduino Uno board, and we can see this is 80 mega 328P, we have used a virtual terminal. Why we have used a virtual terminal? Because we want to see the elapsed time of the two programming methods that we have used. And these are the input switches. These are the resistors of 10 kilo ohm connected to the ground. And again, these are the LEDs that lit blue color when they are turned on. And from here, PD1 or TXT, it is connected to the virtual terminal of RXT, virtual terminals RXT, and RXT is connected to the TXT of the virtual terminal. Now, first, let me load the hex file. I have already compiled it. This is the program of using function. Let me give me a quick brief of this function, what is of this programming, what is happening. So we have initialized 4 variables for the switches. These are 2, 3, 6, 7 pins. Then we have declared 4 variables for the LED pins, which are 8, 10, 12, 13. Now these 2 variables are for calculating the elapsed time. Now we have setup. We have used the function setup or method setup, where the LED pins are for the output and button pins are for the input. Then we have start this function macros. It calculates the elapsed time in microsecond, and serial.begin 9600 to initialize the serial communication. Now this is the loop method, where our Boolean expression has been implemented in logical terms, and obviously we have used inbuilt function digital write and digital read to do the read write operations, obviously. And lastly, we have calculated the elapsed time using the micros function, and this will be printed in the virtual terminal. Our compilation is done, so let me take the hex file address. Yes, I'm taking the hex file address, copying it and putting it in the program file. Okay, I have uploaded it. Now I will run it. Yes. Now what is happening here? Let me pause it. It is showing the elapsed time for this program using functions, this implementation. Now if I open this, so for 000 input there should be 0101. So let me give the, as it is running, so this should be 0000, and we are getting D2 T0, so which is equivalent to O2 and O0. Yes, it is working. Let me show you another one, which will be 1100. So 1100, it is giving us D2 D1, and let me see, 1100 is, yes, D2 D1. Okay, now it is fulfilling. Now let me stop it and upload another hex file, which is my register level programming. Now in this program we have not used any inbuilt functions, which are digital read and digital write. For this you have already given us hints how to do it here, that our main 3 target ports, to select our target ports and to do the same work that the digital read and digital write does, but this actually improves the elapsed time a lot. So here is the code. Same, we have declared variables for button and LEDs, and we have also implemented the macros, and this is the Boolean expression. And here is this important codes of line that, oh sorry for that, the Proteus the described version gets switched off without my okay. Let me I have already run this and I will upload it now. Okay. I'm copying it now. I will upload Control V. Okay, done. Now I have run it. Yes. Now here is the interesting thing that we are getting elapsed time of 8 microseconds, which is quite improvement over using the functions. So let me check this one 0301. Okay, so I will run it again 301. I am getting D01. So yes, this is actually working D01. And if I check another one 1001. Okay, 1001 D1 D0. Yes, D1 O0 O1. Okay, this is also working fine. Now I will stop it and minimize it and get back to my report. So I have taken these screenshots and they are 4 plus 4 8 screenshots for 2 programming methods. Now this is the main part of our project, result analysis. We have seen this box, this column basically represents the data for programming using functions, and this column represents the data for register level programming. We can see here the program storage space was 2598 bytes for using functions, and this one to 2032 bytes register level programming to less program storage space. In percentage, we can see programming using functions took 8% of the memory and register level programming took 6% of the memory. Also, while global variables are saved in dynamic memory, programming using functions to 209 bytes and register level programming to 206 bytes. Although both took 10%, but we can still see their register level programming actually takes less bytes. And most importantly, the elapsed time of program using functions is 48 microseconds, and register level programming is 8 microseconds, which is, if we compare, quite it is very quick, and it is compared to very fast. It takes much less time compared to programming using functions, and there is a detailed discussion about it. And anything else so yes, I have already now, as this is a group project, obviously my group members has to show their work and their contribution to our work. Now I'd like to invite my group mates to demonstrate a few input-output combinations in the simulation and showcase it.
Hello, Assalamu alaikum. My name is Abdullah Al Maruf. I am from section 2 and my group number is 3. To build this project, we use function level code and the generated hex file we use in this Proteus. And to make this project, we use 4 resistors. Each of them are 10 kilo ohm, and we use virtual terminal for the elapsed time, and we use 4 LED and 4 switch. Now I will check them. I will check 0100. I'm sorry, I forget to run 0100, and it is showing D3D1. That means 0301. 031 is correctly working. And then I will check 1100. 1100. 00, and it is showing D2 D1. That means O2 O1. O2 O1. Yes, it's working correctly. Thank you.
Hello, Assalamualaikum sir. This is Muhammad Ibrahim Khairullah from Group 3, and I'm going to demonstrate a few outputs for the simulation. For the simulation to work, we imported the Arduino hex file from the Arduino code and using function programming and loaded into the Arduino Uno circuit here. And now if we try out our given inputs, we can see the desired outputs. So our table is here. So if we try I3 is 0, 0, 0, if we put every input into 0, we can see that here we can see our output number 2 and output number 1 it will be output number 2 and output number 0 will be 1 1. So here we can see the LEDs are on here, and if we try out the second input where I3 is equal to 1, and if we just click it here, and we can see the desired outputs for our second row. So
Thus, in conclusion, uh, we have completed the required tasks that were to be covered. We have compared the program memory size, variable memory size, and program execution time, which is the elapsed time, and also the answers to these questions are in this report, which you will be seeing. And most importantly, we have also implemented the hardware for this project, and a quick and short demonstration video will be added in the end with brief discussion uh, uh, that will obviously fulfill all of our works, that we have actually implemented the software part using simulation and two programming methods, and also implemented the hardware part using physical Arduino Uno, LEDs, register switches, and executed our work with required outputs, and in short, fulfilling our project. Thank you very much, sir. If there are any questions, please let us know. Thank you.
Hello, sir. Assalamu alaikum. My name is Abdullah Al Maruf from Group 3. Here I will show our hardware implementation of our project. Here we use four resistor, or each of them are 10 kilo ohm, and here is Arduino and there is breadboard, and we use four button to give input, and the output will show here O0, O1, O2, O3. As the by default all of them are all input are 0, so it is showing O2 and O1, O2 and O0. I'm sorry, O2 and O0. And now I will give input 1 0 0. Here I will press 1 1, and it will show O2 0 0 1 1. Yes, it's working. 0 0 1 1. Now I will give input 1 1. It will show 0 1 1 0. Yes, it's working perfectly. 0 1 1 0. And this was the hardware implementation of our project. Thank you.